Hello, I welcome you all. The problem reads that the towing force acting on the 400 kg safe varies as shown on the graph. Determine its speed starting from rest. When t is equal to 8 seconds, how far has it traveled during this time? Alright, so we have a problem coming from the Engineering Mechanics and Dynamics, our 14th edition. By RC Hibbeler, and in this particular problem we're being asked to determine the speed when t is equal to 8 seconds, as well as the distance, okay, the displacement, right, covered, or the distance traveled, right, during this particular time. Okay, so what do we do? Of course, we are using the principle of linear impulse and linear momentum. So we are saying summation of the force times the time, or the area under the graph, which is just equal to the area, in our case, under the curve, okay, just equal to m delta v, where our delta v is just equal to v final minus v initial. So we have v initial equal to 0. We have t also, t naught equal to 0. We have s naught equal to 0. Then here we have t here equal to 8 seconds. V final, this is what we are looking for, and we also need this. Okay, these are question marks. Great. So we are using this concept here, and our mass here is just equal to 400. Our mass is equal to 400 kgs. Okay, so we have the mass here. If we are to draw this acting through the center of gravity like this, and we have the reaction force like so. So this is the reaction force, and this is our weight, which is just equal to mg. So let's write down this now. So the area under this curve, let's call this area 1 plus 2. So say this integral of f dt is just equal to area 1 plus area 2, and this is just equal to a half times 5 times 600, this is newtons and seconds, plus that trapezoid area 2 half by 600 plus 750, then 8 minus 5, then this is equal to 400 m. Okay, then we have v minus 0. Our v final, which is equal to v, and this is equal to 0.5 by 5 by 600 plus 0.5 by 600 plus 750 by 8 minus 5 divided by 400. So this gives us 8.8125 meters per second. Right, let's now calculate the distance traveled during this time, that is from 0 to 5 and then from 5 to 8 seconds. Let me just create some space like so, and I guess like so. Great. So like we said, of course, this is area 1 or area 2. We are still using the concept of linear impulse and momentum. So where are we? So we are in the first interval. I would say and t from 0 to 5 seconds. All right, so here we go. So we are saying our area in that region, no, our integral of f1 dt is equal to m delta v. So let's find these equations first that governs the equations that governs these areas. Okay, right. Okay, so the first one, the first equation, this one, again we are using this concept of y is equal to mx plus c, where m is just a change in f divided by the change of, so let me just write properly this one. So we are saying f is equal to mt plus c, where m is equal to the change of f divided by the change in t. Okay, so m1 is just equal to 600 minus 0 divided by 5 minus that, and this just gives us a 120, right? Is that so? 120. The intercept is 0, so this one is just f1 of t is equal to 120 t. Okay, then the other one, this other one, we have m, change in f is just a 750 minus 600 divided by 8 minus 5. This is 150 divided by 3, and this is 15. And then we have f equal to mt plus c. Let's pick one point, so say 600 equal to 50 by t, which is a 5, plus c. Therefore our c is just equal to 600 minus 250, which is equal to 350. Therefore this just becomes f2 function of t, this is equal to 50 t plus 350. Okay, so found these equations. These are the equations that we intend to use. Okay, so let me just write this in its complete state. This is just v1 minus v0. We know our v0 here is just equal to 0, and here we are integrating from 0 the time, because our t 0 is equal to 0, to t. Okay, to t. All right, or we can even call it t1. Okay, so if we did the integration here, then we'll have 0 to t1, and our f1 we say it is just a 120 t, and the t, this is just equal to 400, and then we have v1 minus 0. Therefore our v1, this we just get our v1 just becomes 120, of course, divided by 2 divided by 400. So this just becomes 0.15 T1 squared. Okay, right, so let's move on to the second step. So we have t, we move on to the second interval t up to 8 from 5. All right, so even here we are integrating That's F2 dt equal to M V2 minus V1. V1 at 5, which is the boundary there, it's just a 0.15 by 5 squared, and therefore this just gives us this one just gives us a 3.75. Okay, so we're integrating this from T1 to T2. So if we were to integrate this is from 5 to 8, and then we have 50t plus 350 dt. This is just equal to 400 V2 minus 3.75. Therefore, V2 is going to be equal to V2 is equal to 50, which is just a 25 by. Alright, let's rewrite this one. It's a little bit longer. We'll simplify it later on. So this just becomes a 25. Here from 5 to T2. Okay. Alright. So it's T2 squared plus 350 T2 minus minus 25 by 5 squared, which is 625, and minus 350 by 5, which is 1715, and this is equal to 400 400 V2 minus 400 by that, this becomes a 1500. So writing this, alright, so we have V2 is just going to be equal to we have V2 equal to that's 25 divided by 400. This is 0.0625 T2 squared, and then we have 350 divided by 400, 0.875. Then we have 625 minus 1715 plus 1500 divided by 400. Then we have a 2.1875. Then we know that our V is just equal to ds dt, and ds is just equal to V dt. Therefore, our S will just be equal to V dt. So S1, this is just equal to integral from 0 to 5 of V1. Now V1 is just 0.15 T1 squared dt. Therefore, if we integrated this, we'll have 0.15 divided by 3 by 5 to the power 3. So this gives us a 6.25 meters. S2, if you wanted, you could include this S1 as one of the boundary conditions, but for me, I'll not include it. I'll just calculate this separately. So we are integrating from 5. I mean, the boundary conditions is from 5 to 8. And we have 0.0625 T2 squared plus 0.875 T2 minus 2.1875 dt. S2 is just going to be equal to 0.0625 divided by 3 by 8 to the power 3 and plus 0.75 plus 0.75 divided by 3, I mean by 2, and by 8 squared minus 2.1875 by 8, and then this we have minus 0.0625 divided by 3 by 5 to the power 3, then minus 0.875. This one is divided by 2, 0.875 divided by 2 by 5 squared, then plus 2.1875 by 5. So this gives us 18.5625 meters. Therefore, S is just equal to S1 plus S2. So this is equal to 6.25 plus 18.5625. So we have S equal to 6.25 24.8125 meters. Therefore, our solution is as follows. We have V at t equal to 8, which we found is just 8 point, we'll round it off this one to just 8.81 meters per second, and then we have the total distance covered, which is just a 24.81 meters. Right. I think this is about it. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my video. Bye bye, and I'll see you in my next screencast.